Alright guys, so welcome back. So we are going to talk about Scala again, right? So now we'll start with evaluation block. Okay, so evaluation block is basically, I would say in Scala, right? You can write an expression like this here, right? So you can say well x is equal to 10, or you can say well y is equal to 20, or you can say well z equal to x plus y. These are three different expressions, is not it? Now, if I say x equal to 10, y equal to 20, and z equal to x plus y, what are you going to get? 30. Definitely z equal to 30, and it would be of integer type. Yes, because you're actually adding two numbers. Okay. However, if you write the same expression in two lines, they will be treated as two different expressions. For example, see here. Suppose, suppose you have an IDE. Okay. Let's do this. Okay. Now I'll go back here. I'll say, well, x is equal to 10, right? And then I'll say, well, y is equal to 20, right? And then I'll say, well, z equal to x plus y, right? So what we did is x is equal to 10, y is equal to 20, and z equal to x plus y, that is 30. Done. Now the thing is, suppose suppose I'm not doing it in REPL, and if I'm doing it on IntelliJ, okay, then by mistakenly also, if you do something like this, if you say, well, z is equal to x, okay, plus y, it was like this, right? See, the previous statement was like this, but what you did is by mistakenly you enter here. Oh, sorry, I should say, you have a line here, and then you wrote something like this. See here, if you write these two lines in a, if you write this line in IntelliJ, but then if you give a enter after this x, then what will happen? Your expression would become like this, is not it? Now see here, what happens is, since your expression is like this, it would be treated as two different lines, right? It would be treated as two different lines, and then z value would remain x, whereas plus y would be just a dummy thing. Okay. Now you can also use Scala. You can also use this braces to force your Scala, saying that, hey, you have to evaluate this. Okay, you have to evaluate this together and tell me the value of z. So let me copy this and I'll say paste over here. Okay, now see here. That's what I was saying. Like z equal to x plus y, right? And you do that, then what will happen? It will be treated as a same command, and x plus y will be evaluated into a z. Okay, so be very cautious with the space and all, because your single mistake over here could give you the different meaning altogether, right? So that's what it is, because in Scala it does not say I will wait for semicolon to terminate your statement, right? It says every line is a terminator, and if you feel the line should, like, if you feel there are some expressions, try to put this small braces and make sure that they go across multiple lines. Okay, now we'll talk about a very important concept. Okay, so now we'll talk about a very important concept, that is any class. Okay, so let's go back. Any class, right? So if you remember, in Java, who is the super class of all every other class? Object class, right? So in Java you have what? In Java you have a package, java.lang package. Inside this package there is a class called object class. Inside the class there is a package called inside this package, Java is a package, lang is a sub package. Inside that you have a class called object class, and this object class is the super class or the parent of every other class in Java. This is the godfather. Okay, whatever class you write, say class employee. If you write a class called a class employee, this class employee is basically the child of object class, directly or indirectly. If you say class A, and if you say class B, and this B is a child of this, then this A is by default a child of object. Okay, so that's how it works in Java. Every class would be basically a child of object class. Okay, and likewise in Scala you have something called any. Okay, in Scala there is a class called any class, which is the super class of every other class in Scala. Okay, and now it is very common to see that in object class there are some methods, there are some predefined methods, right? And there are some predefined methods like equals method, has code method, okay, and notify, okay, and then a lot of methods. We'll look into that. Okay. So in object class, you have a 5, 6 methods, right? So you will also see very similar methods are also available in your any class. Very similar methods are available in the any class as well. Let's look into that so that you can understand it more in detail. I'll show you through browser and then we'll okay. So now let's go to the API documentation. You just have to say Java API documentation. So just say Java API documentation. Okay, I'll show you how to browse the documentation, right? So go to any documentation, Java 7, Java 15, does not matter because object class is there since the day one. Okay, so anything is okay, right? So let me go to 7, and here you have a packages. All you need to look into is lang package, right? So java.lang. Okay, so java.lang, click on it, and here you will see there should be a class called object. Okay, so this one, right? Object. So let's look into this object class. And if we see the definition, it says class object is the root of the class hierarchy. Every class has object as superclass. All objects, including array, implements the method of this class, right? So what are the methods we have? Let's see here, right? So we have a equals method, we have finalize method, we have get class, we have has code, we have notify all, wait, different versions, right? So I'll just write some of the important ones which I feel equals get class. I'll write. Okay, so I'll move to the board. Hold on. ToString. How do we forget that ToString? And so on. Okay, so if you see you have a ToString method, you have notify all, has code, and so on all together, right? Now I'll go back to Scala documentation. You will say Scala documentation. And we said that in Scala there is something called any, right? So let's go to this Scala documentation and just go to this API. That's how you will browse. Okay, and in this API you can choose which like API you want to look into. So maybe I'll say 2.13.6. Let's go to the library API. Okay, now here you can search for that any class. You search it here. Okay, you just say any. Right, when you say any, then if you see you get something called any class here, right? So click on it and let's see what it says. It says class any is the root of the Scala class hierarchy. Every class in Scala execution environment inherits directly or indirectly from this class. Starting with Scala 2.10, it is possible to do this and that. We'll not talk about that, but right now what is important is the very first line, right? So if you see, any is a class which is a super class of every other class, right? Any class, whatever you write in Scala, they are directly or indirectly the child of any class. Okay, so any class, whatever you write, would be basically the child, direct or indirectly child of this any class, right? And this class has got some important methods. Let's look into this method. The method, if you see, are like equals method, ToString method, has code method, each instance of method, as instance of method, equal, has, and not equal. That means, don't you think this looks very similar to your java.lang.object, guys? So if you see these methods and java.lang.object method class methods looks very similar, right? So they have the similar kind of method. Like you have ToString method, you have equals method, you have has code method, and so on. Right? So remember one thing, in Scala, any class is the super class of every classes. No matter what class you create, they are directly or indirectly the child of this any class. Okay, it's very important for us to understand this hierarchy. This is really very important. So I'll just go back again. I'll share my screen. Now let's look into this. Any class has the below method like get class, not equal to, has, equal, as instance of, equals, has code, is instance of, and string. Okay, and then for more information, please look into this particular any. Now, any class is further extended by any val, any ref, and nothing. What do you mean by that? That means any is a superclass, we know, but then it is further extended by any ref, any val, and nothing. Okay, so this diagram is very important, guys. This diagram is really very important. It talks a lot about it. Okay, and I'll go back to the screen again. We know this any class is the super class, and in this any class would be basically extended by more classes, right? And more importantly, what we are interested in it is any val, okay, any ref, right? And then nothing class. Nothing is a class, right? So they are basically the child of your any. Okay. Now again, if you want to see those any ref, any val, and nothing, again you have to go to the API documentation, right? So let's move on. So this any class. Now if you want to say, hey, I want to check the any val, right? So here we go. Again, if you see, they are also class abstract class, anywhere extends any. So they are the direct child of any class, right? Again, go back and then you can say any ref we have seen, any val will see, right? They are also the child of this. And let me also say nothing. So this is also a child of any. So there are so many, right? So the major importance are these three right now, okay? But then we'll move on. We'll be exploring a lot of classes, right? So yeah. So now let's look into this diagram, guys. This diagram is very, very important, okay? So the diagram says there is a super class called any, done, we know it. And in this any, there is a child called any ref, scala.any ref, okay? And then you have scala.anyval. And in this anyval, if you see all your data types, the primitive data types, whatever you have seen, right? They are basically the child of anyval, right? So if I talk about integer, int, if I talk about sort, if I talk about byte, if I talk about float, if I talk about double, boolean, char, they are all the child of anyval, okay? Just like a variable, right? So all these data types, if you see, all the data types are the child of anyval. Very, very important, okay? Now Scala any-ref, and if you see in the bracket, it is written java.lang.object. What does it mean? It means, see, in Java, java.lang.object is the main class, right? Now that main class is basically, equivalent to any ref, but the only difference is all the method of java.lang.object are actually moved into any. Remember, try to understand this. See, we all know that in Java, the main class is what? The main class is java.lang.object, right? And in object class, there are so many methods, right? And then every classes, whatever you implement in Java, they are the child of what? They are the child of object class, is not it? And they wanted to do the same thing. Okay, they wanted to do the same thing. So what did they did? In Scala, they created something called any. And they said, okay, this would be the godfather class. This would be the class of everybody. And what we will do, all the similar method, whatever we saw in object class, let us try to put them in your any. And why did they do that? Because it has more hierarchy here. It has one hierarchy at anyval and the other hierarchy anywhere. Okay, but then this anyval is used only is extended only by the primitive types here, right? If we talk about primitive types in Java, so they are basically the child, right, of this anyval, right? And then what they said, okay, let us do what? Let us create one more class called any reference, right? Any ref means reference. So let us create another class called any ref, and what we will do, this would be the parent of all the classes and objects, okay, which are not really a variable kind of stuff. See, at the end of the day, in Scala, everything is class and object. But what they did is to make the life little simple. They said, okay, we know that in Java we have 8 primitive data types. So what we'll do is in Scala they are all classes, right? But then what I'll do is I'll try to make sure that all these classes are extending separately by anyval. Okay, all these classes are extending separately by anyval, and anyval in turn would be extending any. Done. Now coming back to this, it says, okay, now any objects, any custom object which are not anyval and all, right, which are not like these primitive types, any custom objects, what we'll do, will make its parent as any ref, and this any ref internally would be a like a child of any, right? So all your objects, whatever you write, right, like your Java classes. All the Java classes, whatever you see, they are actually a child of any ref in Scala, and internally any ref is a child of any in Scala, right? So your Scala objects, your java.lang.string, and all your Java classes, whatever you write, if you are using it on a Scala environment, then they become the child of any ref. Okay, and then you have a separate something called Scala nothing, which is again extended by null and so many other classes. Okay, so I hope you understood this diagram. This diagram is very important, guys. Now let's talk about that. I just want to quickly recap that so that there is no confusion at all. Okay, so remember one thing: in Scala there is a main class called any, right? There is a main class called any. Now, for now, only remember this. Okay, there is a main class called any, and this any is this any has a lot of classes, right? Out of which any value is one, right? And then you have any ref, and then you have nothing, and so on, right? Now, this any value is basically designed to have all the primitive types, whatever you see in Java, right? So there are classes like integer, float, boolean, unit, all these classes, right? All these classes are the child of any value, right? And then in any ref, you can have your Java objects, java.lang.string. You can have Scala objects, Scala classes, I'll say. Okay, and whatever class you write in Scala, the moment you say class employee in Scala, then they become the child of any ref, not any val. Okay, any val has the fixed childs, all the primitive types. So when I say primitive types, remember one thing, I'm referring to that integer, boolean, float and all, right? Because in Java, in Scala, you do not have primitive types. So when I say primitive type, that means I'm talking about the same old Java story. Okay, but then in Scala, they are all what? They are all classes. They are all classes. There is nothing called primitive data type in Scala, right? The moment I say primitive, that means I'm referring to the Java version primitive. Okay, so that's how it is. So you have any val which has a lot of childs. You have any ref which will have a lot of childs. You have nothing which will have a lot of childs. Now in this any, you have all the methods, right? Like toString method, toString method, and then you have hash code method. Okay, and you have equals method, and so other method, and so on, right? So all these methods are put here so that it can be used by all these childs, as well as all these childs, right? But then if as I told you, if you look into the java.lang.object, then you should basically say this is equivalent to that. Okay, java.lang.object. This would be equivalent. Okay, but what they have done, all the methods, whatever is available in java.lang.object, they have moved it to one step up because it has to be used by this guy also, right? And that's the whole that's the whole point. Okay, so you can say java.lang.object is equivalent to any else, right? Except the method of this object is moved to any so that it can be consumed by the other folks as well. Okay. Now this is a good question from one of you, and the question is very simple. In Java, we have like primitive types like integer, float, boolean, and all, right? As well as we have a primitive types. We have a wrapper classes called integer, float, boolean, and so on, right? And so on. Where do they fall in your whole Scala hierarchy? Number one, this integer, float, boolean are all primitive types. They are really not classes in object, right? They are not classes in object. So they will not come into picture anywhere. Okay. Now this integer, float, boolean, these are what? These are Java related classes. Java related classes means they are the child of object class. Do you agree with me? Because it is from Java. And if they are the child of object, then you should follow here. They all would be treated as the child of any ref, not any val. Okay. This is different than this. The wrapper class of Java and the classes, integer, float, boolean, and all, of Scala are totally different to each other. This integer float boolean are not the child of anywhere. They come under this anywhere because at the end of the day they are all classes. Any classes or object except this primitive, right? Except this integer float and all would be the child of anywhere. That's the important point you need to take away from here. Okay, now let's move on. Okay, let's move on and we'll explore more. Okay, so now the next thing I would like to talk about is the data types in Scala. Okay, so we have just understood couple of data types, integer, float, and all. But let's go in detail and let's understand what are the data types you have in Scala and are they similar to your Java or not? Okay, so I'll just erase this out. In Java, you have primitive types, you have a wrapper classes, right? But then in Scala, everything is classes and objects. Okay, so we are now going to talk about data types. Okay, so the data type in Scala is very same as of Java. Okay, I'll write it down here. We'll start with Boolean, number one. Okay, Boolean, then I'll say byte, right? I'll write it on the hierarchy. Then we have char, then we have sort, then we have integer int. Okay, then we have float, then we have long, and then we have double. So these are the main data types in Scala, and then you have also something called unit. Okay, and then you have something called unit. Now let's understand each of them, right? So see, like this will consume 1 byte. This will also consume 1 byte. This will consume 2 bytes. 2 bytes. 2 bytes. Okay. This 2 will consume 4 bytes, and this 2 will consume 8 bytes. Okay, so if you see by consumption point of view, how much storage it basically takes. This 2 takes 1 bytes, this 2 takes 2 bytes, this 2 takes 4 bytes, this 2 takes 8 bytes. Same as your Java. Okay, and unit you do not have any such description. Okay, because it is just to represent the void type. We will talk about that also in detail. Okay, now, okay, so this is what the data types we have, right? Now let us talk about these bytes, right? So see. 1 byte is how much, guys? 8 bit. Okay, so I should say Boolean should, if I tell you, then Boolean are actually, are not defined. They are actually not defined. Like we just say that it takes 1 byte, but it should not take 1 byte. It should take only 1 bit. That's not it, because it's just a 0 and 1. Okay, but then if we talk about this byte and char, see, byte, this will store only what, true or false. To store true and false, only one bit is enough. Okay, we talk about this byte, 1 byte. So 1 byte is how much, guys? 8 bit. Okay, so let's say this is 2 bytes, so 16 bit. 2 byte, 16 bit, right? 4 byte, so 8 into 4, 32. Okay, and then 8 bytes. So 8, 64 bit. Now, what do you mean by this bit? See, if you look into the computer memory, right? The computer memory is all about an array of boxes, right? And each boxes are what? Each boxes are a bit. It can store either 0 or 1, binary, right? So let's say this is your complete hard disk. This is your complete RAM. Okay, and let's say this RAM this is a memory, right? So these are memory. The memory would, to help you understand, let's say these are all memories like this. Okay. Right. Now see here, how many boxes I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes. 10 boxes, right? So each of these boxes has the capability to store only 0 and 1. That's what we have been learning since our childhood, right? That the computer stores the information in form of 0 and 1. The funda is same. So these boxes are called as bit. these boxes can store only 0 and 1, and these 0 and 1 are called as a bit, right? One bit, right? So if I say byte is going to store take one byte, that means 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. So from here to here, right? So this much space would be consumed. This much space would be consumed by your byte, right? To store this data all together. Now, when I say 8-bit, so see, they are capable to store either 0 or 1, 0 or 1, 0 or 1, 0 or 1, 0 1 or 1, and so on. Okay. Now, out of this, 1 would be just a sign bit. 0 means positive number and 1 means negative number, right? So this would be a sign bit. Is not it? So this would be a sign bit. So now the leftover is how much? 7. In this 7, you should store some data. Okay, in this 7, you should store some data. So 1, 2, 3, 4, 5, 6, 7. 7 boxes would be used to store the data. The first box would be used to store only the sign, right? If it is 0, that means it's a positive. If it is 1, then it's a negative number. So you have only 7 boxes to use. Okay, and all these boxes are capable to store only 0 and 1. That means only 2 elements. So now the formula goes 2 to the power 7 to 2 to the power 7 minus 1. What is the value of 2 to the power 7, guys? 2, 4, 8, 6, sorry, 2, 4, 8, 16, 32, 64, 128. Okay, so 128. So this is 128. Okay, a minus symbol to 127. And this is what you call the range of a byte. This is what you call a range of a byte. That means if I have a variable of byte type, then you can store any value from minus 120 to 127. Okay. Having said that, let's say there is a school and that has a class 1 to 10, right? So they teach people from students from class 1 to class 10. And let's say each class has section A, section B, section C. And let's say every section can have maximum 100 students. So if you're designing the software for that school, then your roll number can be a byte. Why? Because the range is 120 minus 120 to 127. You can always say roll is equal to 100. You can always say roll equal to 5. You can always say roll equal to 2, and so on, right? And that is how basically your byte would work, right? So minus 120 to 127 is the size, and hence it can store the data in that way, right? So like you have to understand how the sizes are calculated. The sizes are calculated because of this formula altogether. Okay. Now you talk about character. Character is 2 bytes. 2 bytes means 16. Now the formula is how much? CR. Minus 2 would be there. 16 minus 1 is how much? 15. 15. Okay. And 2, 15 minus 1. 2 to the power 15, how much it comes? A big number, 32767 or something like that. Okay, 32768 minus symbol would be there. Sorry, it would be 8 here and it would be 7 here. We'll look into that number. Okay, so likewise, again, this sort can store the data to 16-bit. Same formula. Int 4, 32 bits. So now the formula would be 2 to the power 31 minus symbol here to 2 to the power 31 minus 1, whatever comes. 64, and this also 64. So again 2 to the power 63, again 2 to the power 63. But then this float and double has a different approach to store the data. We'll talk about that. But right now, let's move to the document. Okay, look into this document. I've written it very neat and clean here. So you can have boolean, byte, char, sort, int, float, long, double, unit, and these are the sizes 1, 2, 4, 8, right? And then formula, like the formula is not available for boolean because it just stores 0 and 1, so it's all 1. Now byte is like, since it is consuming, it's going to take 8 bits, but out of 8, 1 box would be occupied by the sign symbol. So whatever is left is 7. So the formula becomes minus 2 to the power 7 to 2 to the power 7 minus 1. So it can store the data in this range. Okay. Character is 2 byte, but then it is not an integer data, and that's the reason that there is no formula, but it can store only the characters, right? So it can store the character from this range to this range in a Unicode format. What is a Unicode? Unicode means every character has a code, and that code is basically called as a Unicode. Okay, every character, whatever you can see, all the English language, Chinese language, Hindi language, anything can be represented with a code, and they are called as a Unicode. Okay. Now we have sort. Sort, if you see what the size of it, 2 bytes. 2 bytes means 16-bit. Okay, and the formula becomes like this: minus 2 to the power 15 to 2 to the power 15 minus 1. That is minus 32768 to 32767. Okay. Similarly, integer is 4 byte. That is 32-bit. Okay, and then how much size it would be? It would be minus 2 to the power 31 to 2 to the power 31 minus 1. And how much it comes? It becomes this number, right? Suppose if I want to store the bank, let's say balance of a guy, right? Then I may probably use this, assuming that people would not come with more than this money, for example, right? But then it is practically not possible, because practically people may have a lot of money, right? So who knows how much money Bill Gates has, right? And it is definitely going to exceed this number, is not it? So likewise, you have to understand your requirement first. What is the requirement, and how much, which data type should be chosen. Now, if you look into float and double, they have their own style of storing the data. And how they store the data is, they store the data like this. They store the data with a formula like, minus 3.4 E 38 to 3.4 E 38. Now, if I divide this 3.4, what you will get? 1.7. So here it is 1.7. You insert 0 at this 3 and 8, how much it becomes? 308. That's how I remember the formula for this float and double. Okay, so the float can store the data from this range to this range. Again, your double can store the data from this range to this range. What is this range? We will talk about this. Okay, now long can store the data from this range to this range, right? So if you see, this is really a big number. So if you feel that I want to store the bank details of a customer, and if you're sure that the bank balance will not exceed, then you can go ahead and choose a long, right? So it depends on what exactly you want to use, right? You can either use byte, you can use character, you can use sort, you can use integer, and all based on your type. If you want to store some strings, then strings would be basically stored in as a character, right? So that's the best idea. But then we have a string data type altogether. We have a string class altogether, right? So why would you even use character? Character is just to store one single character, just one single character. And string is basically the sequence of a lot of characters. You want to store a sentence, then you should use a string, right? But then if you just want to store a simple word in Hindi, then you can just use one character, because that one character can store it very easily. Let's move on. Since all the classes are directly or indirectly child of any, we can still call all the method of any class on any of the child object. Let's look into this practically. I'll say, well, x is equal to 10. Okay, now see here, I defined x is equal to 10, and since 10 is a number, by default, any number would be treated as integer, not byte. Okay, please be very, very clear about this. Every number would be treated as integer. So, well, x equal to 10, it gave me x is equal to 10, right? And then I can say x dot, just hit tab. Okay, just hit tab, and it will give you the help. It will tell you what are the methods you can actually call. Okay, and then if you see this get class method, if you see this hash code method, get class method, equals method, they have all come from your any class, right? They have all come from any class, and that's how it is. So I'll say x dot get, again hit tab. Then this will give you the list of what are the method you have. If you have only one method called get class, you just say get class, right? And it's saying yes, it is of integer type. Okay, and again you can say get class dot get name. It says it is of integer type. The class name is integer. Okay, now again you can say x not equal to 11. This is an expression. This should return you either true or false. X is equal to 10 already, right? And then I'm saying X is not equal to 11, true, right? Because they are not equal. Okay, let's move on. Now you can say X dot has code. Has code is 10. So let me tell you one thing. Has code is is basically a method in your java.lang.object class, and in Scala it is a method in in Scala.any class, right? So in any class there is a method called hashcode, and now it depends on how they are implemented. Okay, they are implemented to return 10 in case of your integer, right? This method is re-implemented in your integer class. Although they are present in this hashcode method is present in your parent class, but they should be re-implemented in your integer class. We'll see that little later. Okay, but then when I say x dot hashcode, it returns you the same number. So remember one thing: any number, if you say hashcode, will give you the same value. Okay, for example, if I say well x is equal to 212, and if I say x dot hashcode, it should return me 212. Any number, if they are number, any number will always return you the same value when you try to print the hash code. That's very important. Okay, that's how they are implemented in Java as well. Okay, so now let's move to the next. Now you can also say x dot has. Okay, this will also give you the same. It is same as your hash code. Dot has is a method which can also give you the hash code. Now you can also say, you can also use is instance of. You can just write some character and then hit tab, it will give you the suggestion. Okay, so is instance of int. So I'm saying, hey, I got x, but tell me if this x is a child of your integer class. Okay, so it says true. Okay, it is saying true. Yes, it is a child of integer type. Now let me also say, hey, is it a child of long? Right? It says no, it is not a child of long, it is a child of integer. Okay, that's what you can do. Now suppose you have a requirement to change the integer to a long, then what you can probably do is you can say as instance of. Okay, you can say as instance of long, and what it does, it converts your x, which is integer, to a long type. So I can say, well, result is equal to, right? So if you see what I did is, x is an integer. We know that x is an integer, right? So x dot as instance of long, that means convert this integer to a long type, right? And once it is done, then it returns you back the result here, and the result is of long type 212. And as instance of can be used to convert the to convert the value from one type to another type. Now similarly, let me try this out. I can say as instance of boolean, right? So it says it gave me some exception. Why? Because they are not compatible. So remember one thing: as instance of will throw you an exception if the classes, the conversions are not compatible. Okay, if the conversions are compatible, then it does it. But if the conversions are not compatible, then it will throw you an exception. Okay, now next, x dot equals 10. So x dot equals, I have to say 212 now, because I have changed the value of x to 212, right? So I'll say x dot equals 212. It says yes, they are equal. Okay, again let me say x is equal to 212. Okay, it says yes, they are equal. So for integer, your equals and double equals works both say similar, and then they both of them would return you true. We'll talk about this again when we revisit our string class. Okay, now again, if you want to convert this x to string, then you can say x dot to string, and what it does, it converts this integer to a string, and then you can hold a variable like this. You can say, well, str is equal to x dot to string, and what you got is you got str with a value 212. That's how it works. Okay, now let's move on. Variable naming convention. So whenever you are creating variables in Scala, make sure that they follow some convention. Okay, and it says all these are allowed, right? So see, all the numbers, all the numbers and letters are allowed. We know it, right? But then It says you are also allowed to define a variable like this. Okay, like if your keyboard supports, you can define a variable like this. You call it theta, right? So theta, and then all this can be used as a variable. Okay, and what are not allowed? These symbols are not at all allowed in the variable itself. For example, you can say variable dollar is equal to 10. This is perfectly valid. But then let's try it out. Okay, I'll say, well, dollar is equal to 10. Right? So if you see, I've defined a variable. The variable is 10, and the variable name is dollar here. Right? Again, you can try something like this. Well, one word is equal to 10. Okay. Now it says it is not allowed. The reason is because the name cannot start with a digit. It can be followed by a digit, right? But then the name cannot start with digit, but can always be followed by a digit. So this is not allowed. Whereas if you say word one, this is allowed. Okay, this is allowed. Again, you can not use dot here like this. You cannot say, well, a dot b is equal to 10. So I'll say, well, a dot b is equal to 10. Right? It is not allowed because it is trying to say maybe a is an object and you are saying dot and then b. Dot is used to refer to the uh, method of an object, right? So like I have a demo class object d, and then I have some method on it. So I'll say d dot m1 to call the methods. So that's the reason it is not allowed that way. But then you can also do something like this. You can just put, you know, what do you call, you know, that is present inside your. It's not even FS office. It's something else, right? So this present just above your escape, just below your escape. Okay, so you can just use this symbol to get these things done. But the question is, why do you want to do that? Okay, so it's really not a great idea. Okay, now this is a very strict recommendation for everybody. I've seen people making this mistake. Recommendation: always use camel casing while naming variables in Scala as well as Java, right? For example, if you look into any class, so let me go back, as I've shared my screen. If you go to any class, right? So see here, any well, what do you see? You see A and V capital, right? And you see dummy I am implicit, so D and I, right? Again, you see all these functions or all these classes not implemented error, right? So I should not say camel case, that's wrong. Variable, right? Oh yeah, that's perfectly okay. So these are the classes, right? So there is a convention why you rename a class. Anytime you create a class, your class should always follow this pattern. The first letter of each word should be capital. Okay, so prefer and for example, look into this, right? So whenever you're defining a variable for your classes, right? Whenever you are defining any property on your class, then you should basically write like this: number of employees. N should be small, O should be capital, and E should be capital. Okay, and please don't use this kind of style in Java and Scala. Don't write number of employees. I've seen people doing this because they come from Python background and they are habituated writing, the variables in this style. Okay, so I'll also put one more line here. While defining variable names, okay, always prefer using camel case. That's one thing. And then I'll also put one more point: while defining classes and traits or and objects, prefer capitalized first word, first character of each word. Okay, example, array index out of bounds exception. Okay, so this is the the convention everybody is following, and we should also follow this same convention, right? So make sure that you are not doing this mistake. I've seen people writing a variable like this in a Scala program. This is really not allowed. Okay, and this is not a practice. Don't do that. Okay. Anybody here who writes a Python, code in a Python style, who uses Python style in Scala code? So let's change that habit. Okay. So if you're working on Scala, then please use the Java standard approach. And if you're using Python, please use Python standard approach. All right. Now, any ref is extended by the below class, string, and null. We'll talk about that as we move on. And any ref can be thought of as similar to java.lang.object, except the fact that all the methods which are available in Java are moved to any class. We've already discussed about this. And any custom class we create will automatically extend any ref. All the Java-based classes also extends any well automatically and not any, right? So all the Java classes, whatever you write, they would basically fall under any, take 1 minute, any ref. That's a mistake. Okay, any ref and not into any. All right. So that's what we have questions. So now let's move on. We'll talk about escape sequence. Okay. So in Scala, you have a lot of escape sequence. And what do you mean by this escape sequence? These are basically a character or symbols, you can say, which can give some special meaning whenever you are doing some, whenever you are writing something, right? For example, you have /b, you have /t, /n, /f, /r, then a single quote, a double quote, and a backslash. So all this escape sequence can be used whenever you want to do something, like whenever you want to print some message and say you want to go, you want to create some space, you want to create a new line, you want to keep your single quote, double quote, and so on. Okay. Now let's move on. So the first one is hello world. Okay. So what I'm doing is I'm trying to print hello world by just giving /b/b/b. Okay. So let's go here and we'll just say hello world, but then I said /b/b/b, hit enter. And what did it give me? It gave me hell world. How did it happen? So we are talking about escape sequence and we are talking about /b, right? What I did is I said println hello, right? And there was a space, okay? And then I wrote /b/b/b, and then there is a space, and then I wrote world. This is what I did. And what's the output? The output is hell, right? So let me go back. The output is hell, then a space, and world. Okay. So let's understand what happened. When you started printing this, when you said, I want to print this message, what happened is, let's see. So hello is printed, say HELLO, okay, and then a space, right? But then /b will erase this backspace, would erase this space, your first /b. The second /b would erase this, okay. The third /b would erase this, right? So you have 3 backslashes. That means you're saying, hey, print hello space, but then you gave /b/b/b. That means erase each character. So first character is erased, second character is erased, and third character is erased. So these are all erased, right? So you got hell. And then there was a space here, right? And then followed the word. That's how it basically gives you the output. So when you try to say hello /b/b/b, each /b actually means give me a backspace, right? So one character would be deleted, and finally you get hell space world. That's how it works. Let's move to the next. Now I'll talk about print hello /t/t world. Okay, so let's go back. Now I'll go back to this hello /t/t world. So hello and then /t means a tab space. Okay, so what it does is it basically gives you some space, some 4-character tab space. Okay, again it gives you a tab, another tab, right? And then it prints you a word. So let's try this out, right? So if you see, there are some spaces. What it does is it basically creates 2 tab space, hello /n world. Okay, so when you do that, what happens? It will print hello, then it takes you to the next line, and then it prints world. So hello and world, right? Again, hello /f world. And what does it mean? It actually means /f is actually a form field. Okay, and let's see this, what exactly it is. Form field is a page breaking ASCII control character. It forces the printer to eject the current page and to continue printing at the top of another. Often it will also causes a carriage return. What does it mean? So it means if suppose you are expected to print this data in your in your let's say you wanted to print this string on your printer. Okay, let's assume. Let me try to give you the output here. Okay, so I'm saying hello slash f world, enter. Now if you see, I got hello, and then I got some spaces around here, and then I got a world, right? But what does it do? It basically, let's assume you are trying to print this string probably on a device, right? So when you say slash f, that means I'm done till here. And when you say slash f, that means take me to the next page. Okay, take me to the next page, and then on the next page you start printing world, right? So you should basically see hello on one page, and you should see hello and world on another page, right? So that's what it is. It is actually supposed to do. Now let's talk about this. We are done with this form feed, right? Let's talk about this print ln hello world. Okay, so let's see what exactly is the output that you get here. So I'll copy this out and then say paste. Okay, enter. So we got the output Voro. Okay, and why we got this output Voro is because what it did is here. It said hello, print hello, space, then it said return carriage, right? And then it said you start printing this on top of it, right? So think about this, like you already printed this on a paper. Okay, you already printed this on a paper, and then what you did, you again inserted the same paper on a printer, and then you said I want to print this. So what will happen? The first four characters would replace here, is not it? Right, it would overlap, right? And you will lose this help, right? Because it will be replaced by space WOR, and you will still get this O. So that's what it is doing, right? So WORO. Again, let's try one more example. I'll say slash R one. I'll just say one. Okay, let's hit enter. Now what we got is we got space 1OR. Let's understand this as well. So I'll just go back to my board, and I'll explain you this on the board. And we have hello, right? And slash R, and we have WOR, right? And then we have slash R, and then we have one. This is what I wanted to print. Okay. Now how do you interpret this? It's very simple. Let's try to first print hello. And there's a space. Okay, hello, and there's a space. Done. Now when you say return, that means take my cursor to the first place. Take my cursor to the first place and start writing this. Right? So what will happen? It will say space W, okay, O R, and a space is also there. In this case, a space is also there. So it will write it like this. And what is the final output now? Your final output would be this here, right? And then you are saying R, that means take my cursor again to the next line, right? So again to the beginning. So it's not the next line. Okay, we are trying to print it again. So again the cursor is going here, and then it is here, and then you are printing space. So you get a space here, and you are printing one, right? And this would remain as it is, right? And that's how your output is space 1OR space. That's what you see on the screen. So that's what you can see the output on the screen, space 1OR space. Done. Next, now let's try to see how do you deal with double quote, right? Now if you say I want to write some statement, but that statement should have a double quote, then you can always say use this backslash and then say double quote to escape the sequence, to include them in your string, right? So see here, println Linux Turbo said talk is cheap, show me the code. And what I did is I just wanted the output to be produced like this, said, and then a double quote, talk is cheap, show me the code, right? So that's what it is. So you just can say escape and then put your character whatever you want to print. Right, done. Next, now if you want to put a single quote, if you want to put a single quote like this, then you can say don't, then you give slash a quote, right, and then it says don't go, right, so it printed don't go. Now you can also do something like this. It means you really don't need escape if you really don't want to, right, it just says it also prints the same thing. You don't have to use a slash to just escape your single quote. Now if you want to represent something like visit us at somewebsite.com, then you will basically use a lot of backslash to represent your single slash. So see here, what I'm doing is I'm saying println visit us at so many slash, right, and what does it do? It basically these two slash out of the, like in this example, the first two slash would represent one slash. One is to escape and the other one is the actual thing what do you want to show. So two slash would represent one slash, the first one. Again, the next two slash, one is to escape and the other one is the actual message. So slash and then www.onlinelearningcenter.in.